Hello, today I'll be talking about binomial expansion using Pascal's triangle. Let's get started. If we have a binomial a plus b and we square this, we already know that this is a squared plus 2ab plus b squared. Meaning, if you have, for example, this is just a format. If you have an example like x plus 2 squared, it means to say you square a, in this case you square x, you double the product of a and b, in this case you double the product of x and 2, so that's 2x times 2, so we have 4x, and you square the second term. So in this case our second term is 2, so our answer is 4. So that's how we expand. Another expansion is when we cube the binomial a plus b. Well, the quantity a plus b raised to the power of 3 is like a plus b squared times a plus b. Okay? And we know that the square of the sum of a plus a and b is a squared plus 2ab plus b squared, and then we multiply this by a plus b. Okay? Expanding this, well, we multiply a and distribute that to all the terms inside the first factor, which is a times a squared is a cubed plus a times 2ab is 2a squared b. A times b squared is ab squared. And then we distribute b, we do the same thing to all the terms inside the first factor. B times a squared is a squared b plus b times 2ab is 2ab squared plus b times b squared is b cubed. Okay? It's a long process, but that's how we do it. So simplifying this, we combine those with similar terms like 2a squared b plus a squared b. Well, there's no other term like a cubed here, so we write a cubed plus 2a squared b plus a squared b is 3a squared b plus ab squared plus 2ab squared is 3ab squared. And then finally, so we added this already, so we only have one left, and that's b cubed. Okay, if you notice, okay, this is the technique. Look at the power of, let's start with the squared. Look at the power of a. The power is, well, the binomial is squared, so the power of a is 2. And then after a term, the power of a becomes 1, and the power of a becomes 0 on the third term. The same goes with b. Here, the power of b is 0, and then the power of b becomes 1, and then it increased by 1, so it's b squared. Okay, the same goes with when the binomial is cubed. Okay, look at the powers of a and b. A becomes squared after the first term, 3, 2, 1, and 0, and then the same goes with b, 0, 1, 2, and 3. Now, how about the coefficients? Look at the coefficients of the squared binomial. It's 1. This is understood that there's 1 here, so that's 1. The second term has a coefficient of 2, and the third term has a coefficient of 1. As for the cubed binomial, the coefficients are 1 and 3 and 3 and 1. Now, our topic today is binomial expansion using Pascal's triangle. And we can easily use Pascal's triangle if we have to, this time, find the expanded form of a plus b raised to the power of 4. And the same goes with the binomial. If it's raised to the power of 5 or 6 or 7, you can go on. Okay? And I would like to show the what's Pascal's triangle is. This is a Pascal's triangle. It's a triangular array of numbers that shows the coefficients of the binomial expansion. Remember, a plus b squared is 1, 2, 1, and a plus b raised to the power of 3 is 1, 3, 3, 1. So that means the coefficients of the expanded form of the binomial a plus b raised to the power of 4 must be 1, 4, 6, 4, and 1. So going back now to a plus b raised to the power of 4, we know that the pattern is a cubed, and on the next term the power of a becomes 2, and the power of b becomes 1, and the power of a becomes, oh, not cubed, it's, let me do it again. Sorry about that. Okay, so this is a to the fourth, a to the third, a squared. I'm sorry about my handwriting. A squared plus a and plus a raised to the power of 0, which is 1. Okay, and then b is 0, b is 1, b goes 2, b is raised by 3, and b is raised by 4. Now their coefficients goes like this: 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So we don't have to go through the process of expanding. Well, this is also effective, why not? But this is much easier if you know the principle of Pascal's triangle and the principle of expanding binomials. Let's go back to Pascal's triangle. How do we know this? Okay, of course we start with 1, okay? Because a plus b raised to the power of 0 is 1, so the coefficient is just 1. And a plus b raised to the power of 1 is a plus b. So a's coefficient is 1 and a's coefficient is 1. Now let me just draw something here. Now if the binomial a plus b is raised to the power of 2, so these are their coefficients. Look at this. Okay, this is 1 plus 1 is 2, 1 is 1. 1 is 1, 1 plus 2 is 3, 2 plus 1 is 3, and this is 1. So this is 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 3 plus 1 is 4, and then 1. And we have here 1. Look at the number above them. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5 and 1. You can go on forever. Like this is raised to the power of 0, raised to the power of 1, raised to the power of 2, cubed, raised to the power of 4, raised to the power of 5. And what if the binomial is raised to the power of 6? What are their coefficients? This is 1. The first term is 1. The second term, 6. The third term has 15, 20, 15, 6, and 1. And you can do the same thing if the binomial is raised to the power of 7. Okay, this triangle is really very much interesting. All you have to do is, well, you start with 1 at the top and then adding the two numbers above each entry to get the next entry. And this is a very interesting triangle actually. And this has many other applications, like if you look at the sum of the entries in each row, it's a power of 2. Okay, look at this. If you get the power of, if you know, get the sum of 1 and 1, it's 2. It's a power of 2. If you get this, the sum of 1, 2, and 1, it's 4. It's a power of 2. 1, 3, it's 4. Plus 3 is 7. Plus 1 is 8. 8 is a power of 2. You do the same thing to the next row. We have here 1 and 4. 5 plus 6. 11 plus 4, 15 plus 1 is 16, which is also a power of 2. And you can go on forever. But I would really like to use Pascal's triangle in binomial expansion. Okay, so that's going to be all for today. Maybe in my next video, I'll be sending you some exercises on binomial expansion. Thank you very much for listening.